So I'd like to cover next is Steve and I are going to do an update on the worldwide marketplace, our Hyperion Research activities. Most of you have seen this before. These are the things that we try to do. We try to track everything sold every quarter. We hold 4 HPC User Forum meetings a year. So for next year, we're still missing 1 international meeting. We haven't decided in the fall for that. And you can see some of the new areas here. We're under the Big Data HPDA program. We're including our tracking of machine learning, deep learning, and AI. And like I said, Steve will be covering some of the initial pieces that I think we've completed 4 studies this year-ish in this area alone. We're trying to do our usual thing, and that is mapping what the whole sector looks like, come up with definitions and categories, so then we just track numbers against that. And you'll see the initial portion of that. And then we've also increased our tracking of cloud computing. Right now we're running a study every 2 months on cloud computing in HPC. So we're trying to track all the different aspects there, and also tracking all the accelerators. Just a quick overview organizationally, we are fully separated from IDC and Oceanwide. There is a tremendous firewall. The only communications that are allowed really are going up through lawyers and the CFO if there's a contract question. So we have the entire assets, all the reports, all the data from IDC has been transferred to us. That goes back 35 years. So we have the entire data structures. And also thanks to CFIUS, which we really love CFIUS because they took care of us, we are tasked to keep doing 100% of what we've done in the past. So it's really nice that it's a lot of clarity for us on that part. So with that as background, I'd like to quickly walk through our recent market numbers. So for the full year 2016, 11.2 billion, record high revenues. Things had gotten a little soft last year, but the previous year. We're seeing some strong growth in the 250,000 and above. There's still a little bit of flatness happening at the very high end of the market, but our view of the flatness there is because there's going to be a massive bounce coming up in the next 18 months. So it's the usual roller coaster up and down portion of that cycle. As far as by vendors, we're still seeing some tremendous shifts on the vendor side. HPE has done extremely well in the last 5 to 8 years. Dell has increased and probably has grown the most percentage-wise. And then you can see IBM and Lenovo as a whole are still struggling quite tremendously, on their portion of the market. In the other category, we track about 35 to 38 different vendors. The reason you're not seeing them separately, the vendors get to decide whether their data is shown publicly or not. So if you need additional tracking, we're allowed to show that separately. As far as by markets and the different verticals, this is our current snapshot of the HPC sector. In addition to this, and Steve will probably be covering that, we have a different set of segments for the HPDA, and we're looking right now for machine learning and AI, whether or not there's a different segmentation there, and you'll see that in the near future. As far as the forecast, we are expecting to see a fairly strong uptick on the supercomputer segment by 2021. With all the exascale programs around the world, all the investments, we're tracking each one of the different sites. The divisional part, also we expect fairly strong growth, but we're looking to see the market for just the server portion to grow to roughly 15 billion by 2021. And then if you include the broader part of the market, so that was just the servers that I've talked about so far, the external storage, middleware applications, we're expecting the market to exceed $30 billion by 2021, with roughly a growth rate of between 6 to 7% for the overall broader market. And as in the past, storage always has been growing a couple points faster than the rest of the market. And with that, I'm going to hand it off to Steve.
Anyways, Earl said the market's headed toward about $30 billion in 2021. And the storage part of the market has been getting more important over the years because of the growth of data and some other factors. And we see that part of the market headed toward over $6 billion, about $6.3 billion at the end of our forecast period, with a higher CAGR than the market as a whole. So that's very strong growth there. The things driving it, no news to, I think, most of you, are the organic growth of modeling and simulation. The computers are bigger. They're running more iterations of the problem. Iterative methods themselves are becoming more popular and even being recognized as part of leadership computing now. And there are new folks coming into the market, particularly at the low end. Then the whole high-performance data analysis part of the market is growing at a faster pace than the rest of the market. We'll see the numbers in a minute. More folks, existing users are exploiting analytics methods, and then enterprise folks, more and more of those folks have been hitting a wall with their enterprise server technologies, not able to complete the work, a day's worth of work in a day's time, and that's pushing people up into HPC, and with some new use cases. And cloud-based HPC is also another source, growing fastest in private cloud, second fastest in hybrid, and least fast, but still at a decent rate in public. This is how the external storage market, the market for storage outside of the computer itself, splits out by vertical. And these numbers correspond pretty well, kind of in rank order to the size of those vertical markets altogether on the server side as well. So there aren't too many big surprises there. Manufacturing, which kind of comes into the CAE portion of this, is growing especially fast, though. This is what it looks like by region. You can see that the growth in storage is a bit faster outside of North America, in EMEA and Asia, than it is inside North America. And then we kind of turn to high-performance data analysis and what's happening in that market. This is getting complicated. We've seen it before. It's starting to look like the last days of the geocentric theory of the universe. But what we've got is modeling and simulation analytics and a kind of convergence of those two things. Basically big data requiring HPC. That's the convergence part. And that part alone is headed in 2021 toward, about $6.5 billion on this for servers and storage. These are the main use cases that we're tracking. Fraud and anomaly detection, tracking faint signals, which is a horizontal kind of a use case that moves across government, industry, academia. Affinity marketing, which is really getting stronger, the use of HPC for retail and so forth. Mathematically, affinity marketing and fraud and anomaly detection are kind of the same problem. One is about excluding and one is about including, but mathematically they're about the same problem, which is why we're finding a lot of organizations using both. Business intelligence is the fastest growing HPC use out of these, but it's starting at a smaller base. Precision medicine isn't really much here yet, but this is the one that promises to be larger than all the others, just because of the size of healthcare spending. This is just a couple of tables from studies we've done. This one we just looked at, not simulation, but big data analytics, just the analytics part of it, and how much of the total HPC workload, all the cycles, are kind of being consumed by big data analytics. And what you see there is that decent portions in government, academia, and industry, but particularly in industry, you see the growth of analytics on HPC systems. This is kind of an eye chart. What it really says in summary are that today, the trend is for people to run analytics and simulation on the same machines if they are doing both. But the longer term trend is to buy separate machines for those things. One of the reasons that people are running them on the same machine today is because it's difficult for them to suddenly go to management and say, I used to buy one machine, now I need money for two. But the workloads are pushing them toward doing these separately because the architectural requirements are different, as you know. So now we come across the kind of the AI portion of it, and we kind of start with definitions, and what this amounts to is that AI is used pretty loosely as a term in the marketplace. It's not really well defined. Machine learning and deep learning are better defined or more easily defined. And so we kind of look at machine learning and deep learning as instances of artificial intelligence. With machine learning kind of being the one that is a lot more difficult to achieve. So we kind of looking at the status of deep learning, because machine learning is kind of out and about. It's happening a lot. Deep learning, not so much outside of the realm of the giant social media and internet companies, but HPC clearly has moved to the forefront of R&D in these fields. But the fields, the ecosystems, these fields were kind of developed by the big social media and internet companies. Those ecosystems are not a great fit for a lot of other markets. That's one of the problems, including the benchmarks. One of the reasons that the social media companies were able to do this is because they had plenty of data. You need a lot of data to be able to do deep learning. In most markets, they do not have access to a lot of data yet, enough data. And without enough data, the results are not going to be accurate enough to be useful. So that's kind of the situation. You can see the quote there from Glaxo, which has a fair amount of data, but nothing like what they need to really put this into practice. But people are spending a whole lot of money already in this field because they know they need to get there. One of the things that's come up that's very, very important in the last particularly 6 to 9 months is the need for transparency. You know, when the DeepMind computer from Google beat everybody in Go, AlphaGo, that game, Google kind of didn't have any idea how that computer beat the humans. After they kind of turned it loose, it learned and did that. But not such a big problem when it comes to games. A big, big problem if it's self-driving vehicles. A big problem if a self-driving vehicle is getting into an unavoidable accident and decides to take out the bike rider on the right instead of the oncoming SUV. The car makers kind of need to know why that's happening. And the insurance companies also kind of would like to know why that's happening so they can fix it. The solution that people are aiming toward, not just for automotive, but for things like healthcare diagnoses, is to kind of affix some kind of an HPC simulation capability to that in order to see what the computer is doing at each instant of time. So here are the forecasts. First row that you see there grayed out is the HPDA market altogether, headed toward about $4 billion in 2021. And you can see the portion of it that is AI related, starting from a much smaller base and getting to be, a quarter of that, about 1.2 billion or 1.3 billion in 2021. This is what it looks like split out by methodology. And we do treat machine learning, deep learning, and so forth, not really as markets. They really are more akin to methodologies like computational fluid dynamics as a methodology. And there are the numbers fully split out for each of those. In your packet, you have this information. By the way, these charts. Earl?
Sure. Thanks, Steve. I've got this. So we don't have enough time to walk through all the different studies that we do, but I wanted to give a highlight just on the return on investment study. And in a about an hour or so, Bob's going to do a highlight on our exascale tracking program. But our most recent ROI data is showing that for every dollar put into an HPC project, it's returning on average $551 in revenue and $52 on average in profits. So the numbers are continuing to be very high. We've included here 2 extreme examples. Whoops, let me go back here. In the oil gas sector and finance that we have not included in the data set yet. We've collected, I believe we're at around 850 examples so far. But the one in oil gas is just amazing because for every dollar they put in the supercomputer resources on the particular reservoir modeling and that, they returned 3.75 billion. So the return was just phenomenal. And then in finance we saw an actually higher one where the return on the revenue was 11.6 billion. So there's some examples we're seeing here where the numbers are just phenomenal that are taking place. We are making all the data sets available. We will be posting the one I just showed in the next couple of weeks at the User Forum website /ROI. And you can see the original full report from the study. The reason we keep the older original full report, that has all the definitions, all the details about how the whole system works. So in conclusions, we still see HPC as a strong growth market. It's because growing recognition around the world of the strategic value and by the private sector and the public sector. As Steve was talking about, the HPDA, AI, machine learning, deep learning are creating an entirely new space that, for HPC, which is tremendous. And we also expect to see a lot of growth in HPC in the cloud. I mentioned before that we're doing a study every 2 months on this. Our concern is that we think that when the clouds get more HPC friendly, you're going to see kind of stepping points where a lot more people use things in the cloud. But almost every place that we survey and measure, it doesn't reduce how much is done on-prem. And in other words, what's going on is people want to do a lot more HPC work than what they are doing today. And so they're looking to the cloud for that next step expansion. We saw a lot of vendor share position shifts, changes and everything. For example, SGI is no longer on our charts because HPE acquired them. So we expect to see some more shifts over the next few years. We're not sure what those are, but we still expect some instability in the vendor base. And but as you see in the same chart almost, there's still some major pain points. Software continues to be the #1 roadblock. Everyone thought that the petascale level applications needed to be redesigned. Almost, I'd say 95% of the applications that we track weren't changed. Right now the feeling is they need to be changed for exascale. At this point in time, since I kept expecting for 10 years, my expectation now has changed completely. I think exascale systems are going to run the old-fashioned software as far as the old workloads and just run lots of them. And then there's going to be new workloads that are going to be designed as opposed to going back and redesigning the old applications. It's very clear in the last 10 years, the pain factor to the user base to rewrite, redesign applications, to recertify them is just too steep of a cliff. And I don't think people are going to make the investments we were expecting over the last 10 years. Storage access time is becoming a major pain point in all the surveys that we're doing. Clusters are still hard to use and manage. They're getting more complex either in size, complexity, different types of processors, different configurations. And it continues power cooling and floor space are just gigantic issues. Part of this is because all the systems are growing in size still. And so if you continually have to buy a larger system, you continually need more floor space, more power, more cooling, as opposed to just growing within the same profiles. And I think Bob will be covering at the very high end of the market how those issues are evolving in detail. So if you have any questions, feel free to send us an email. And with that, I'd like to hand it back to Paul to introduce the morning session.